Hello and welcome to More with Expected Value. The first problem we're going to look at here is if we roll a dice, would you like to play this game with me? So let's make a table, a distribution table here. If you roll a 1, BIBSA pays you $30. So this will be our roll. This will be our money. You make $30. Congratulations, I gave you $30 if we roll a 1. If you roll a 2, BIBSA pays you $5. Okay, you make $5 on that one. If you roll a 3, you win nothing. Good game, right? You make $35. But if you roll a 4 or a 5, you must pay $10. Okay, well that's 30 in the plus or 10 in the minus. And if you roll a 6, you have to pay $20. Okay, the next thing we're going to need is probabilities of these things happening. Let's do probabilities here. What's the probability that we roll a 1? That is 1 out of 6. Probability that we roll a 2 is 1 out of 6. Probability we roll a 3 is 1 out of 6. Probability we roll a 4 or 5 though, that's 2 out of 6, or 1/3. Probability when we roll a 6 is again 1 out of 6. Now to find expected value, all you do is you multiply each winnings or losings by its probability. So we're going to take 30 times 1/6 plus 5 times 1/6 plus 0 times 1/6. I don't really even have to write that because this is 0. Plus, not plus, minus 10 times 1/3 minus 20 times 1/6. And let's see what this thing is equal to. Each probability, each money, winnings, times the probability that that will happen. 30 times 1/6, that's just the same as 30 divided by 6, that is 5. 5 times 1/6 is 5 divided by 6, that is 0.83. 0, I'm not even going to write that. Negative, this is 3.33, and this is also 3.33. So I've got 5 plus 0.833 minus, this is going to be 6.66. So if I go 5.83 minus 6.66, that is negative 83 cents is my expected value. That means that over the long term, I should expect to lose 83 cents each time. And that's what I would write out. Do not play this game with Mr. BIBSA because over the long term, you will lose on average 83 cents each time you play. You might hit it big and win $30 one time, but if you keep playing, BIBSA's got you. Next problem. We've got the prize times the probability of winning. This is a lottery. So the first question says, what's the probability of winning nothing? Well, the probability of winning nothing is just 1 minus the probability of winning something. So let's add up all the probabilities of winning something. 10% and 8% and 6% and 4% and 2%, all these together, if you add up just these, that's 30%. So you have a 30% chance that you win some amount of money. So 1 minus 0.3 is 0.7. The probability that you win nothing is 70%. The probability you win something is 30%. Together they add up to be 100%. Now fair price for the ticket, that is expected value. So again, we need to take the money times the probability that we win that money. Plus $2 times 0.08, plus $4 times 0.06, plus $10 times 0.04, plus $20 times 0.02. And here we go. This is going to be 5 times 0.1. That is 0.05. This is 0.16, this is 0.24, this is 0.4, and this is 20 times 0.02, 0.4 again. When I add all those up, I get, this is 40, 40, 40, that's 120 plus 5, $1.25 is the expected value. That means if I buy a lottery ticket, I should expect on the long term, that lottery ticket to be worth $1.25. If I buy 1 million of them, I'll make $1.25 on each ticket that I buy. So this says that they're only going to sell the tickets for $1. And the Lottery Commission is pretty excited about all the money they're about to make. What would you tell them if they expect to sell 1 million tickets? Well, if they sell 1 million tickets, they're going to bring in $1 million, but they're going to have to pay out $1.25 times a million. I'll go with that over here. $1.25 times a million, that is 4 zeros. 1,250,000. So this is not good for them. They're going to bring in $1 million, pay out $1,250,000. So they're going to lose $250,000. Or you could also think, hey, if they're selling it for $1 and they're going to lose $1.25, they're going to lose a quarter on each ticket. So you could also do 25 cents times a million to find out how much they're going to lose altogether. Bad lottery for them. They're going to lose money on this lottery. Next, insurance problem. We've got an average claim is about $3,500. So every time there's a crash, they have to pay $3,500. For every 1,000 drivers who are 16 years old, there are 61.4 collisions or files are claimed. So in this group of 1,000 drivers, it says for every 1,000 drivers in this group, how much money would you expect them to have to pay? Well, they're going to have to pay $3,500 every time there's a crash. And how many crashes are there in this group of 1,000 drivers? There are 61.4 collisions. This is a true stat, actually. I looked this one up. 1,000 times 61.4. That's a lot of crashes for young people. That means 61,000. Oh, no, wait. Multiply wrong. Scrap that. 214,900. That's how much money they're going to have to pay all together. For all the crashes, out of 1,000 drivers, they have to pay this much money, $214,900. So how much is it fair to charge for one person? Well, we just need to split that money over 1,000 people to make it fair. So let's just divide it by 1,000. And that would be $214.90 per person, so that those 1,000 people cover the cost of the $214,000 the insurance company will have to pay. Last question. We've got a charity. 5 prizes. We've got a car, a bicycle, a vacation, and 2 TVs. That's $600 each. Okay, so we want to look, first of all, what's the fair price of a ticket? Well, fair price, we want to look at total amount of prize money divided by tickets, to see what's the fair price for one ticket. So we've got 25,000, just going to add these up, plus 800, plus 2,800, plus there's 2 TVs at 600, so I'll go 600 and 600. Total is $29,800. So that's the total amount of money they're going to be giving away, and they're going to raffle this off over 10,000 tickets. So let's divide by 10,000, and I'm getting $2.98 per ticket is a fair price for the ticket, for total money divided by total tickets. If you buy one ticket, what's the probability that we win a prize? Well, there are 5 prizes I could win, so there's 5 ways that could happen out of the 10,000 total possibilities that there are. So this is the best answer here. If you buy 10 tickets, what's the probability that you win a TV? Well, I have 2 chances for every ticket for a TV, so times 10 would be 20 chances out of the 10,000 tickets. Hope that helps you with expected value. Have a great